Awesome. Super excited to talk about building on LayerZero. I think this is a quick introduction. GM, my name's Matt, developer ecosystem lead at LayerZero Labs. And I figured if we were going to talk about bridging, one of the most important places to start would probably be with the London Bridge, right? Real quick, just as an analogy, I think bridges obviously connect isolated groups of people, but more than just people, the really interesting bit is they connect information. And with information, you can do a lot of interesting things. You can coordinate the exchange of goods and services between these isolated groups and parties, and you can also create financialization between isolated groups using that information. Within crypto, it's very much the same thing. When we talk about blockchains versus L1s, L2s, et cetera, you're constantly deciding as a user and as a developer to make trade-offs between speed, cost, security, and also communities on top of each of these developer ecosystems. So really, when you're building, you'd like to figure out, how do I communicate between kind of these isolated islands? This has become more of a reality over the past year. If you look in 2023, the Electric Capital Developer Report saw that over 30% of developers in the space are working on more than one chain, and this number has significantly been growing year over year. And I think this makes sense, because if you look at the blockchain ecosystem, you have all these separate islands. However, you need a common way to communicate between each of them. And ideally, if you're going to create some generic standard for how you message between different chains, it needs to uphold the core principles of the blockchain itself. Namely, one, it has to be permissionless. Anyone or any smart contract can interact with it and interact in a way where they can't be censored, right? They can't stop the flow of messages between two different blockchains and prevent those islands from speaking together. And finally, it has to be immutable. You can't have code that's upgradable that can potentially brick your implementation and also brick every other application built on top of it. But taking a step back and looking a little bit closer to kind of the most standard form of application on a blockchain, token transfers, with one blockchain, it's relatively simple to know who you're sending from and who you're sending to. You're just updating the underlying ledger. But as soon as you move to more than one blockchain, you immediately have a problem. You have these walled gardens and these chains that don't know about each other. So how do you have a common standard of interacting between them? Ideally, we want some way to be able to transfer our funds on the source chain, get that debiting interaction to work, and then notify the destination chain to receive that asset in a way that doesn't violate any of the previous principles. Traditionally, the way this was done was using some type of monolithic bridge security. In the middle, the way you can think about this is a centralized provider or some type of collection of signers or a middle chain. It doesn't really matter. There's one validation technique that sits in the middle between these two chains. But what happens when that validation fails? This isn't more of a what if, but an actual literal scenario. If you look at the history of bridging, time and time again, applications promise some type of validation that securely transfers messages from a source to destination, but at some point, a validation technique either becomes stale, outdated, it fails, a backdoor is unlocked, there's a lack of client diversity, and what ends up happening is not just you, the application builder, but every application builder that touched that validation technique is now suddenly at risk. Looking at the history of blockchain, you can clearly see out of the 5 largest attack vectors and hacks that we've seen in the space, 4 out of those 5 were due to this type of monolithic bridge security, where one validation technique fails and every application underlying it is immediately, essentially pwned, right? This is from the Rect leaderboard, you can check it out yourself. And going back to kind of that narrative we have about cross-chain being a reality, where we have different trade-offs that developers and users make between different blockchains, why should bridging be any different? Why should I have to subscribe to one monolithic model of security, one monolithic model of bridging, in order to move not only information, but assets between chains? Clearly, a better approach would be to have some type of standard for an omni-chain application, where I, the developer, not only have control over how these pathways interact and what validation techniques are used, but also know that my configuration is unique in a way where not every application is suddenly at risk when one validation technique fails. Looking at how LayerZero solves this, this is from our omni-chain fungible token standard. At a high level, looking back at that token transfer logic we talked about earlier, all the OFT brings is a standard ERC20 token and implements a special debit and credit logic on the source blockchain and the destination blockchain. But the really interesting bit is in the middle here with the security stack. All a security stack is, and the way you can think about it, is another configurable field that an application owner can apply any access controls that you normally would have to, whether it's pausable, providing some type of multi-sig, et cetera. But what it applies in the middle is the ability to choose not only the size of security validation techniques that you're using to verify messages between chains, but also the type of validation techniques that are used. At a high level, what this means is that when you deploy on LayerZero, not only can you control the validation techniques that are part of this overall security stack, but in the worst case scenario, if one validation technique outright fails entirely, your flow of messaging is not stopped in any way, shape, or form. You can continue message passing safely because you have collectively signed and said, I want, let's say, 2 out of these 3 validation techniques to prove that this message is legitimate from a source blockchain. You're not underlying risk from just one validation technique that could fail at any time. Looking at a high level of how this actually works, any application, whether or not they're using our contract standards, can communicate with a LayerZero endpoint contract on the source blockchain. That message uses a configuration that you own as the application owner that's stored on-chain in a message library. That message library controls not only what security stack you're communicating with, what validation techniques I'm using, but also how I want execution to happen on the destination chain. From there, configuration of those security signers will basically attest that that message is legitimate using each their own validation techniques. In the previous example, you saw there were 4 verifiers. There's 3 validation techniques that out of that 4 have to sign off here. It's enforced on-chain, on destination that, hey, this is the configuration of techniques that I actually want. And then that message can be permissionlessly executed by any user or automatically executed by a production asset that LayerZero runs directly to the destination app all through the protocol. And what this means is that when you're looking at LayerZero and trying to build a cross-chain application, you don't have to subscribe to any one model. You can actually include all of them or any size, shape, or form of this collection for your security stack, whether that's a ZK Lite client that aggregates 300,000 signatures on Ethereum, whether it's a traditional messaging service like CCIP, an established Web2 entity like Google Cloud for sanity checking that, hey, this is actually making sense and I want to have some kind of insurance on the back that makes sure that this message is legitimate. It doesn't matter. You can configure any size, shape, or type of validation you want for LayerZero messaging. And broadly, what that means is that your application is future-proof. As new verification schemas come out and become more available for the average developer and average user, you can easily configure your security stack to add that schema on board. Outside of just validation techniques, some of the other interesting bits that you can control are the block confirmations, for example, that you have to wait on a source blockchain before a message gets emitted. This protects you from reorg risk if your, let's say, application is based on a source chain that has high frequency reorgs that mess up the validity of transactions. You can configure, again, the security stack. So if I wanted, say, 2 out of these 3 validation techniques to sign off a message is legitimate. You can also abstract away gas from your users. Using automatic message execution, a user can only pay in a source blockchain's gas token and have that entirely swap for them on the destination chain for a 5 basis point fee and automatically delivered to the destination chain for execution. Or if, let's say, that executor disappears at any point in time, any user can permissionlessly execute that message on the destination chain as well. There's no limitation for what you can do here. On top of those executor gas settings, you can actually dive a little bit deeper and specifically price how much gas I want to use for the receive logic of my transaction. So let's say I minted a token on the destination chain. I have the amount of gas limit I'm providing, the message value for minting that token, and then I have a secondary transaction I want to execute after composing on that token transfer. So let's say I want to take that minted token and swap it for an ERC20. I can use the compose logic to not only define the gas and message value I want for that transaction, and I can also add native drop options to drop native amounts of gas to a wallet. Let's say I need to fund an externally owned account to help a user's onboarding experience on that new chain, or just fund a contract for it to use some type of pull method to pull that gas for a subsequent transaction. You can also configure the order of messages. By default, messages are unordered. So if a message fails in delivery, the subsequent nonces can continue to be executed without blocking the pathway. But let's say I have a niche scenario where I need to develop, let's say, for governance, being able to store that, hey, these users voted specifically in this order before a timestamp. I can configure within the application level that I want, if message 2 fails for some out of gas reason, that nonces 3 and 4 are blocked until nonce 2 is retried and cleared. Outside of that too, you can also configure the max message size, helping you standardize the data type that's actually being delivered on the destination chain, protecting you from overflow or underflow of inputs from a source. Really, what you can do with LayerZero is extend composability. Instead of having to rely on packing all of your contract calls into one singular function and hoping that it succeeds, else it reverts, you can instead atomically pack out multiple messages on the destination chain that you want to add on to your transaction. So in this example for here, I want to receive that OFT and immediately swap it as its own atomic transaction, thereby guaranteeing that if that swap fails, the minting on the destination chain still occurred successfully. Overall, this builds into what we view as an omni-chain tech stack, where any application, no matter what your use case is, can communicate freely with a LayerZero endpoint contract on any blockchain network and configure not only all of the settings aforementioned, right, but also know for sure that you're not at risk of any validation technique suddenly becoming outdated, prone to vulnerabilities, lack of diversity, etc. And so we're going to dive into a live coding example, and fingers crossed this goes well. That's our new CLI toolkit. I'll pull this back up at the end, but we're actually just going to jump right in right now. So here we go. All right, so just to get started, all you have to do to start building on LayerZero is run one really quick command, lz oap and latest. Make sure you're using node version 18. What this is going to do is create a boilerplate repo for you. Ignore the formatting there, a little bit funny, but basically it'll ask, hey, where do you want to start your project? Do you want to use the omni-chain fungible token or just the broad data passing layer? We'll choose OFT. What package manager I want to use? Do I want to install the dependencies? It'll pull everything down. And while we're waiting for those to get installed, taking just a brief preview of what is included in this repo, you can see that for contracts, it pulls in the basic OFT contract. All that OFT contract has is just, again, my OFT is inheriting the OFT standard. OFT is an ERC20 token. Asks you about, hey, what's the name of your token, the symbol, what LayerZero endpoint for what chain you're using, and then an owner for that contract, right? From there, you also get brought in some tests for you. You have Foundry tests and hard hat tests enabled by default for this package. If you want, you can use one or the other or both. Totally depends on what you want to do. But the greatest thing I think that helps with omni-chain development is this hard hat config extension we've done. So super normal hard hat config. The only difference is that you have the inclusion of an endpoint ID that identifies, hey, what chain are we actually working with here? And then this LayerZero config file that basically extends that endpoint ID and says, these are the contracts that I expect to be working with on each chain. You instantiate them as part of the connection, and then can define whatever config settings you want in here. For lack of time, I'm going to jump to a repo I've already set up and jump in here. You can see I have three main contracts. I have an OFT mock, has an open mint function. Don't worry too much about that. I have this swap mock, which pretend this is a contract that you want to actually interact with on the destination chain. All it does is basically takes a composed message in, and it says, hey, once I receive an OFT from this token, or from this contract, transfer that ERC20 to the designated receiver on the destination chain. And so what we'll look at really quickly here is actually running this send and swap command. All I'm going to do is use this task that I built ahead of time that just says, hey, I want to send from Avalanche Fuji to this destination, Arbitrum Sepolia. I want to send to this swap contract address an amount to swap, a minimum amount to swap for slippage, and then these gas options, right? I want to use 200,000 gas for the minting and 50,000 gas for the composed swapping. This encoded composed message is just arbitrary bytes. You can pass anything in here, but let's run it and see what we get. So hopefully the internet works and my gas is funded, but we should be good to go here. Once we run this task, we will get out a transaction hash that we can plug directly into LayerZero scan. And so we're going to open. It takes a minute to index just for the source chain. Should take 15 seconds or so, provided nothing's gone crazy. Great, there we go. And so we can see from Avalanche Fuji, this is the transaction fee that we paid. We know who the sender is from the source chain. We know that the cargo within that transaction is one mock OFT that I'm sending from Avalanche to Arbitrum Sepolia. And then while that message is being delivered, it's going through those different validation techniques that the security stack is configured. And then once that validation is confirmed, the message will automatically be executed, and this will update automatically for you. You can see here, it tells you what the source application is, what the destination application is, the amount of gas we paid for the receive logic, the amount of gas we paid for the compose logic. You can see this execute button pops up once we know it's verified. You don't have to use this, but this is just in case the executor fails. You can see now we're confirming that the transaction is legitimate and we're delivered on destination. And so if you check my wallet balance here, you can see that I had 78, I'm down to 77. I hop on over to Arbitrum Sepolia. This mock token, I now have 10 of from 9. And if we actually go to the contract address, just to check that this hash is legitimate, we can see, great, down here, this LZ receive method was called. We got our minting at least through. And then from the compose end of the logic, what we'll do is just pull up the swap mock contract deployment on Arbitrum Sepolia. Nice. And pop on over to Sepolia scan. Great. Check ERC20 token transfers. And just to confirm, at the top here, you can see 1 minute ago, an OFT went in, and 56 seconds ago, that ERC20 came out to my address. And so really the limit is kind of endless here. You can do anything that you want with sending arbitrary payloads, and you're good to go as far as making sure that your messages are A, verified, that you know that anyone can come and permissionlessly execute these messages, and really start composing more and more protocols and more applications across multiple blockchains. LayerZero also allows for message passing from, let's say, I want to go from chain A to B to C and any other legs that I want to go. All of that can be packed within your send logic, and you can have multiple kind of nested calls within one send transaction. But yeah, that's it for the presentation. Happy to take some questions from here.
Hi, thanks for the presentation. I actually have two questions. The first one is there any easy way to migrate from V1 to V2? Because this is the V2, the new one, right?
Yeah, so there are two things that come with LayerZero V2. There's the integration of that security stack, right? So if we talk about this end, right, being able to choose any provider as part of your security stack, that can all be migrated from V1. The way that this works is if you look in this transaction flow, we have a message library. The message library is append only. So for LayerZero V2.
So the entry point is the same.
Exactly. For for V2, what you can do is basically just say, hey, I want to use this new validation library that was appended to the registry, and you can start using the security stack and executor setup.
All clear. Thanks.
Yeah.
And the other question is testing omni-chain, like cross-chain protocols is quite hard. So you showed the example on the testnet, which was actually deployed. Do you have some kind of library that allows you to transfer locally without interacting with blockchain?
I do, yeah. So we actually have this Foundry package called Test Helper, which recently got put out. We had to update it to OpenZeppelin v5 for some core dependencies. But what it lets you do is locally in your Foundry test define, hey, here's some mock endpoint IDs. I want to use 1 and 2. I want to deploy an OFT on each of these endpoints, define some users, and then test through essentially wiring these contracts together, minting some initial balance, and then testing the send function locally. All you have to do from this end, should just work out of the box once I pop in here, is just run your normal Forge test commands, then we'll be good to go. But yeah, Test Helper, you can find docs on docs.layerzero.network, and everything within that repo that I published will kind of show you kind of how to work through a lot of the local examples as well as kind of the deployed examples through testnet and using LayerZero scan. Yeah, any other questions?
Hey Matt, great job. You mentioned something about native drop messaging. I think it was about potentially airdropping to make it easier for new users not to pay gas. Yeah, what was that?
Yeah, so basically within your executor options, I think I showed you when we were doing that send example, there's that add executor LZ receive option, block of gas, add executor LZ compose option. This .native drop option can be another one that you append onto it. All you do is basically add that configuration to your send call with a destination receiver address and then an amount, and you can airdrop that destination chain's native gas token direct to that address, all as part of the send call logic.
Okay, cool. Thank you.
Yeah. Cool. Any other questions here? Or are we good to go? Like I said before, feel free to try out this package while you're hacking. I think it's super handy to get up and running for cross-chain applications, and we have 2 bounties, one for OAP worth $2,500, one for OFT worth $2,500. So thanks so much for having me, guys.